I really hope it's not a trend. It's fundamental for humanity in the sense it's really about decision making, a framework to have a better decision making process. Curiosity is the key component here.
Hey, Causal Bandits. Welcome to the Causal Bandits podcast, the best podcast on causality and machine learning on the internet.
Today we're going back to Berlin to meet our guest. Born and raised in Bogota, Colombia, he did his Ph.D. in geometric analysis before geometric deep learning became popular. He attended some of the most prestigious conferences in his field just to realize that pure math doesn't make him happy. He decided to make a transition to data science and became one of the leading advocates for using causality in marketing. Ladies and gentlemen, Dr. Juan Orduz. Let me pass it to your host, Alex Molak.
Ladies and gentlemen, please welcome Juan Orduz.
Hi. Hola.
Hola. ¿Qué tal?
All good, thank you. I am very happy to have you here.
Beautiful. Thank you for having me here.
It's a pleasure. Actually, I guess coming to Berlin is always a pleasant thing.
For me, definitely. And I love the apartment. I love this openness here and the space.
Thanks.
It seems you really love Berlin. What's so special about the city for you?
Well, actually, I came to Berlin 12 years ago because I got a scholarship to continue with my graduate studies in math. Living as a student in Berlin is really great because you get exposed various type of universities, a lot of young people, a lot of diversity and energy. After that, actually, I tried to escape from Berlin just because I wanted to do something else, but I couldn't because I liked the city so much. And I think it comes to the fact that it provides so much diversity, so much energy and things to do, that actually it's a perfect city.
It seems that your career is also diverse. You did your PhD in pure math, but now you work in a very applied context.
Yeah, I guess I get bored pretty easily, I would say. And that kind of brings me to try to explore different type of fields. So I guess even at the very beginning, I started with physics and I was very into particle physics, but then I realized that I like particle physics not because of the physics, but because of the geometry. So I think I find it quite nice to have this non-linear path, and let's see what's going to happen next.
And how was the transition for you from the academic thinking and the academic culture to the industry?
So, I mean, I guess when I started the PhD, I kind of wanted to continue with the academic path. But then life happens. I was doing research in a very specific field, which I like quite a lot. But I realized kind of the impact and kind of people that would appreciate my work was very limited. And also I spent 5 years just talking with mathematicians. So at some point you feel like it's not the real world. And kind of the breaking point was that I was at the Fields Institute in Canada, attending one of the most kind of prestigious conferences in my field. And I was not happy. I was away from my family. I was away from my friends, and I was like, okay, even if I stay here longer, I wouldn't enjoy it. And at that time, I kind of went to a library and actually I bought one of these books that I still have that is called Data Science for Dummies, just because why not? And then I guess at that time, that was already September 2016. I was very close to finishing my PhD thesis, and then I started this moment in life to try to think about what could be next. I had no idea. I was lucky enough to meet some people in Berlin. Again, that's the nice thing about Berlin. You meet a lot of different type of people, and I talked about what they'll do. And a former a student of my graduate school was actually doing data science. And among all of the possibilities that I heard, that felt the most interesting for me. It was not that hype at the moment, so I didn't choose that because it was kind of hot, but I generally thought it was like a good field for me to apply it, what I had learned. And then, but I was also aware that I had to start from scratch again. So really trying to understand these data problems from a business perspective and not an academic point of view. And that was pretty tough, I would say.
Mm-hmm. Does the perspective of pure mathematics help you when you deal with applied stuff?
Absolutely, because math doesn't give you like just theorems or tooling, but it teaches you how to learn to solve problems. So when I'm faced with a very hard problem in industry because of various reasons, not just because it's hard by itself, then I always think, okay, let's do it one step at a time. Let's try to break up the problem and then take piece by piece and not get overwhelmed by a problem. Kind of, you're not scared to tackle something which might be ill-defined. And on the other hand, you of course have a very strong toolbox. For example, think about linear algebra. I always think about and talk about linear algebra as a fundamental field where if you have kind of good knowledge about it, then most of what people do in the industry can be reduced to a certain type of linear algebra problems. So in that case, kind of it gives you the fundamentals, and in addition, kind of this perspective to tackle problems and not get scared the first time you see it.
In your blog posts that you share with the community, you very often use Bayesian methods. And at some point, I noticed writing your post, your blog post, and everything you share, that there's more and more content that is related somehow to causality. What was the point in your life when you realized that this causal thinking might be something that can be helpful for you and the problems that you deal with?
Yeah, so I guess I knew I needed causality from the very beginning, because one of my first positions was dealing with marketing analytics and marketing problems. And kind of the way they wanted to kind of estimate, for example, media efficiency or optimize budget was using kind of traditional statistical models, let's say linear regression. Of course, they wanted to test many things, and I guess the recipe was to throw everything into the model and try to hope for the best and do kind of really kind of, strange tricks which didn't feel natural to get out of this outcome. So you could always torture the data to get a story. I was always thinking like there should be a better way, but I did not know about the language. And I guess because of different reasons, I turned my attention into Bayesian modeling. And one of these great books about the topics, which I strongly recommend, is this book, The Statistical Rethinking by Richard McErlett. And I mean, the book is really about Bayesian statistics, but with a focus in causality. So there's like a chapter about DAGs and confounders. And I remember the first time I read that, I was like, okay, what the hell is that? Like, I had no idea what this guy is talking about, but it seems like a very, very powerful tool. And I guess it was not just because of the proper conceptual or academic interest, but really because I saw as a potential tool to help me solve the problems that I had faced in the past. And I think through that and kind of resources which were not that popular at that time, not is like as I had your book at that time, I kind of made my way into trying to understand this better, but really into the applied setting.
What are the main differences that you see in causal approach versus traditional approach that we see in industry today, especially in the context of marketing where most of your expertise is today?
Yeah, I mean, I guess the challenge is really because it's such a, I wouldn't say complicated topic, but something that you really need to structure in a kind of conceptual framework that people might get scared or lost. So just to give you a very concrete example, thinking media mix model problems where you want to estimate media efficiency by putting, costs or impressions to try to explain a target variable like conversions. Kind of the intuition that marketeers have is that you need to just throw all the data or all the channels into the mix so that they compete each other in this regression framework, and then you get some return on investment or variable importance. But the problem is that the marketing funnel is rather complex because you have a kind of TV, for example, out of home or paid social, try to create awareness, but there are other channels like search, which are already in between these initial touch points and the final conversion, because you see an ad, you get interest, and then you potentially search about it, and then you get the conversion. So this is kind of a mediator effect, and if you just throw everything into a model, it's going to give you bias estimations. It's not going to work. What you need to do is really identify which channels and which type of effect you want, which in essence is the DAG of your assumptions. And based on that, you might need to run one or a couple of models to actually extract these effects. But for people, it's really hard to grasp the fact that to get good estimations for media efficiency, you need to leave certain channels out just because they're going to create, or like they're going to mask the effects. And it's hard to communicate. And of course, I can not just come with Pearl's book on causality to try to explain that to marketeers. It's really try to get intuition into something that might not be intuitively easy to understand.
What are the tools that you are using in order to communicate with stakeholders or with people who are in marketing and maybe are not as technical as you or other data scientists might be?
Yeah, actually, I found that trying to go with pure theory or kind of fundamental argument is not very successful, at least in my experience. And you need to show them something, like prove something. And this is where I see simulations as a great tool, because you control the truth and you can tell them, okay, I run a simulation, I simulated a couple of uses, and I know that the return on investment of this channel or the effect of this intervention or campaign is positive. And then let's put everything into the model and see what we get, and we can get really misleading results. And not that they're slightly wrong, but very wrong, which can make you take decisions which can make you lose a lot of money. So when you show them the effect and say, I know the truth, this is what we get if we do it kind of a naive way, then they get more convinced without needing to get into the details of causal inference and the concepts behind it.
It seems that Bayesian framework, in terms of Bayesian structural, let's call it modeling, is a very well suited tool for this purpose, because it's a natural way to work with these models, to simulate the data, to just allow the information flow through the model and sample from the model.
Yeah, I mean, I guess what I really like about the Bayesian framework is that it forces you to explicitly state your assumptions on the data generation process. So if you want to run a simulation, then you need to think this properly. And of course, you want to also understand, let's say, where this variance or variability is coming from. And that's where kind of setting up certain type of distribution and also putting some domain knowledge into that, it's really helpful, because you really want to have these simulations in a scale that the user can understand. So euros, conversions, and so on and so forth. So you really need to understand what are your assumptions, so that, based on that, you will get certain results. And in that regard, kind of the Bayesian framework, thinking about the data generation process, comes very handy and when thinking about causal DAGs. So it's not like a huge step, but it becomes kind of natural. Thinking about this kind of data problem as a causal structure.
Was the fact that you have experience in physics and then Bayesian modeling helpful for you to go into causality?
I think at least what you get from physics, it's really try to model the phenomena without overcomplicating it. Meaning that, of course, really trying to extract a causal structure from the real world, it's very hard. And if you want to do it perfectly, then you're probably not going to do anything, because it's very hard. But then you can start simple. Okay, let us simplify what's the essence of the problem. What's the most fundamental thing that you believe you can model and parameterize in a way that it makes sense. And then you start adding kind of complexity and experimenting with the data. So it's not that you always need to go to the most complex DAG or more complex problem. You start simple and iterate. And in that case, I guess the background in physics, for example, I guess particularly is where these ideas have helped me quite a lot.
What causal tools did you find most helpful in the beginning of your journey with causality?
Tooling, as in kind of books, software, or
I meant more on a conceptual level at this stage.
I did kind of face this problem of trying to understand the DAGs and kind of what could go wrong. For example, what if we condition a collider? So that was hard, but it was actually the way that I found it more useful, so to say. So it took me some effort. I wouldn't say this was for free, but having the concept of a model as a graph, such that you just state your assumptions and then pass this to a software or do calculus or whatever. And then you don't need to kind of be clever about it, but really systematically and conceptually get the model structure that you need to estimate, let's say, in a linear regression. So I really like the concept of thinking about the problem as a DAG. I think it very naturally you think about nodes and connections. But of course, it takes some time to get into the framework, but definitely thinking about DAX made everything much transparent.
What would you say to people who want to start with causality and they feel a little bit intimidated or unsure how to construct their first DAC? Maybe they are a little bit afraid that it will be incorrect, or they feel they don't have necessary experience.
I mean, first of all, I don't think it's easy. And as Richard Mark Erlach would say, if you're feeling uncomfortable and confused, it's because you're following. I would say it takes a bit. Even I feel sometimes uncomfortable because, again, it's really about stating their assumption, but it definitely pays off. So it's really an investment. And even with the very basic fundamentals, like, okay, I have a simple model. Which variables do I need to add into the model to have a proper estimation without including any type of bias? That's already a big win. So seeing it as an investment, which is definitely going to pay off, like a guarantee that it's going to pay off, bring kind of momentum and energy to people getting into the field.
Mm-hmm. And you mentioned this iterative process, that sometimes you start with something simple, then you add something, then maybe you run a simulation. How do you communicate with stakeholders the value of this process? I
mean, first of all, we should always get simpler because of the speed, right? So let us assume I want to solve a specific problem. Certain, they need some results, right? If we start with something complex, it's going to take longer. It's going to be riskier. Of course, it's not going to be easy to get the buy-in. So if you state something simple and think about what's the easiest thing you could do that makes sense, then you can deliver that and start working on top so that people kind of get an impression of what's the end result and how is it going to look like, and see how they will use it for decision making, and then iterate on top of that. So thinking about additional features or uncertainty quantification. Is this something that they really want to use? You might postpone that for the second iteration. So really trying to think about it as an iterative process, because at the very end, kind of at least in industry, kind of speed and when having results, it's important. So, I mean, if you're going to have a perfect model in a year, that's pretty much useless, right? Because we need to make decisions now.
Mm-hmm. You are now in a professional transition. So you used to be a senior data scientist at Wolt in the marketing team, and now you're transitioning to the pricing and forecasting team. What are the main challenges that you see in this transition regarding the approach to modeling, approach to causality?
Well, I did work a bit, at HelloFresh in forecasting, but it was a kind of smaller scale. I was doing what is called strategical forecasts or strategic KPIs to make specific driven decisions. Of course, we want to do this in an automated way and scalable way, but we're talking about maybe 20 to 100 time series. Now what we face at Wolt is really like a massive set of time series, so you really need to make sure that the scope and the variables and the methods you choose should scale well, right? So I guess that's the difference. Like, you won't be able to see and analyze all of time series. You want to really kind of extract the main features in a clever way and in a way that it scales. But I still think, kind of, again, coming back to where I find things interesting, like changing fields and seeing how one can kind of include knowledge from one to another and also keep learning, is actually something that I find very interesting.
Mm-hmm. Today, one of the super hot topics is the intersection of causality and large language models. Looking from a perspective of a person working in marketing, pricing, and forecasting, do you find any areas where this could be useful in your work?
I should say that kind of following both the literature in causal inference, Bayesian statistics, and the rest of the field is very challenging. So I probably don't know enough about LLMs to really answer this. I do see there's a lot of potential regarding creativity and kind of thinking about whether you could kind of optimize the way you communicate with people in a kind of automated way and be able to experiment a little bit more. But I think still in a very early days, because again, when you do marketing and you have a campaign, you really need to be careful about the message and the way you communicate, the tone, and kind of letting kind of such a model to do this for you can actually hurt the brand. So kind of what if the model has an outlier or unexpected response, then that can hurt your brand quite a lot. So I guess, at least for me, what I feel that this type of models help is actually in boosting my productivity through, for example, GitHub Copilot and a lot of these kind of productivity tools to actually speed up the process. But with respect to specific marketing, I think we're still in the early days, but maybe I haven't followed the latest trends recently.
Mm-hmm. So you find it useful for just speeding up your work, making it more efficient?
Absolutely. I try to use it as much as possible, thinking about code, also thinking about text summarization, also kind of summarizing calls, and things that you can automate. This is something that definitely I use quite a lot.
Which causal tools are the most useful in your toolbox, in your work?
I guess thinking about, again, coming back to the fundamentals, I guess once you have the DAG and you have specified the problem, then you can actually move forward very fast. So I guess in that sense, we're kind of agnostic. I guess if you have the concept properly stated, it's gonna be fine. If the model is simple enough, I usually do it myself, PyMC fan, so I will probably write the model myself. If it gets more complex or you need anything more sophisticated, there's no reason to rebuild anything from scratch. So kind of popular Python libraries out there like DoY, EconML definitely have been very useful for my work.
Mm-hmm. When you think about methods coming from different causal traditions, let's call them. So we have this graphical tradition that comes from Perl. We have the potential outcomes framework and methods that come from econometrics, synthetic control, or other quasi-experimental methods. Do you use both of them? And are there any ways that you try to combine those two different schools of thought?
Yeah, I guess maybe I'm a little bit of an outsider because kind of I haven't followed the details kind of in a way where I can see how this branch. I actually believe they complement each other quite well. So I started looking into Rubin's approach on potential outcomes. It was much easier for me to understand. It makes sense. And when you need to have certain type of estimations and you need to pick up the set of regressors in such a way that you have a proper structure to do the estimation, then in that regard, kind of having a graphical model and having the do calculus to automate this for you comes very handy. So I don't see them, at least in my work, as kind of two separate branches. I see if you can combine them together to get the best out of both worlds.
What would be the main advantages of using DAGs when you already use quasi-experimental methods?
Again, I think that DAG, independently on whether if you are going to do causal inference or statistics or any type of analysis, it forces you to state your assumptions. And that's hard. But once you have done that, then you are aware about what could be the potential limitations or whether it might be unfeasible to run such a estimation from the observational data that you have. So even if you don't use the DAG itself to specify your model, thinking about the data generation process, the connections, again, going from simple to complex is something that is going to make your work more transparent, again, because how explicit you need to be in when doing so.
And this advice is on fire. I think everybody should hear this because we sometimes might forget that quasi-experimental methods do not guarantee causal identification out of the box, which sometimes, depending where you started your journey, you can get an impression that is the case. So some people might expect that if we use synthetic control, for instance, there's no chance that we will have some hidden confounding. But as long as we do not have a structural model, we actually cannot exclude this possibility.
Yeah, absolutely. And I'm always very careful about kind of not trusting the data and trying to challenge my own assumptions and just wrongly that, which again, people might feel is the hard part. And I do feel the harder part because then you really need to think about the problem and the domain. But again, this is kind of the great starting point. And yeah, this is like a must, but it takes time to get this and actually acknowledge that this is going to help you instead of being kind of a blocker or like something that it might be unnecessarily complex to solve a specific business problem.
Mm-hmm. When somebody is just starting with Causality and they want to do it specifically in Python, what would be your advice? Where should they start? Would it be go and do stuff with PyMC, with DoY, EconoML, maybe some other packages?
So actually, I like quite a lot the approach of this book, Causal Inference, the Brave and the True, by Matteo, because he actually builds up kind of the concept and uses stats models for the estimation. So he's not focused on the estimation or whether we use Bayesian or frequencies or even the p-values, but it's more about the structure, right? So I guess at the very beginning, you should be focused on the concepts and not be distracted by the estimation, because once you have that, then you can just select your favorite library. What I would advise not to do is just choose a library because it's hot and try to make put a lot of data and hope for the best. Really focus on the fundamentals. If you need to write your linear regression in R, or we're talking about Python, but in stats models, for example, that's already a great start. I wouldn't kind of overcomplicate things at the beginning by combining various type of estimation methods.
So that sounds like starting from the scratch and building those models on a little bit like lower level.
Yeah, which is fine, because again, if you understand the fundamentals, everything's gonna be easier later. But if you have if the bases are kind of weak, at some point that's gonna bite you in the future, and things gonna become very confusing. And then you don't know if it's because the library is broken, or you don't know the concepts well, or somewhere in between.
This approach reminds me of what we can experience in mathematics as well. If you skip something in the beginning, then it might be very, very hard to build a more advanced or more complex concept later on.
Yeah, and I guess coming back to this point, when you have certain type of math problem, you have this theorem of a structure of a theorem where you says, let us assume this, and then you have a result, which means what you need is actually essential. And if you take one of these hypotheses, the result might break. And when you start proving theorems, you don't want to start from very weak conditions, but actually very strong ones, and see up to which point you can remove unnecessary conditions to get the minimal set of assumptions so that your result holds true.
Mm-hmm. We had a lunch a couple of days ago together, and we had this very interesting conversation related to a PhD about symmetries in physics, in very fundamental view on the structure of reality or what we want to understand as reality. Is there any way that you see that this thinking about symmetries can be also useful in modeling?
Absolutely. I think it's essential, and again comes to the fact of this kind of well-known theorem, Noether's theorem. We would say that, at least in physics, that whenever you have a symmetry, there's a conserved quantity. So if you have, for example, rotational symmetry, then the angular momentum is conserved. So even if this feels quite a bit away from modeling or even industry, the message is clear. Like if you see there's some pattern, let's say symmetry, then you can use that to be more efficient in your computation. So just to give you a very concrete example where this kind of gets illustrated quite well. If you have two circles which are in the same center but with different radius, and you want to split these two with a clustering algorithm, you cannot use k-means. I have that example in my blog. And you can do something fancier, for example, spectral clustering. But if you realize about kind of the symmetry, you actually, if you express this in polar coordinates where you have the radius and the angle, then you can actually forget about the angle, and in the radius space, this is linearly separated. So of course you could try something more complex like spectral clustering, but you really think about the problem and say, okay, actually I have this symmetry. If I use that in my advantage, I can actually reduce the problem to something very, very simple.
It reminds me of what we do in causality sometimes as well. So if we are able to fulfill certain assumption, so we say, hey, in this case, we can get something for free if an assumption holds, then we could do things in a much simpler way, right? With maybe interventions or simulating interventions or even computing counterfactuals.
Yeah, exactly. This is where you, let's say, again, everything, or not everything, but most of things come to geometry, and the symmetries that you are looking into can come into different type of structures, but I guess the most common structure is in geometric objects. So thinking about the The circular examples is really the space of the point, and in this case, in the causal setting, it would be the DAC itself.
When we talk about causality, and in particular Perlin causality, we have this hierarchy of causal levels or ranks of the ladder of causation, and as it is metaphorically expressed sometimes. When we move from association through interventions towards counterfactuals, we can think about having different formal languages for each of the ranks, and each language gives a richer description of a phenomenon. Is there any association here that you could do with the idea or concept of symmetry here, the richness of structure, the richness of description with assumptions?
Maybe, but I don't have anything on top of my mind. But I do agree that kind of going from one level to another, it has to be about language and kind of concepts about how you cannot use just the do operator to do counterfactuals, kind of calculus, so to say. So I guess not at the moment, but again, I'm not really a researcher, so I'm more of a practitioner. But I wouldn't be surprised that this type of tool can actually help us to get a more efficient understanding, especially when it comes back to estimation and inference.
In marketing, we sometimes use those methods called geolift. For many people that come from the outside of marketing, this concept seems or might seem very, very complex. Could you give our audience a little bit of an insight how those models can be constructed and if they are really, really very complicated?
I mean, whether it's complicated or not, I guess it depends on the background, but I would say in essence what you're trying to do is to actually have a way or a tool to estimate a counterfactual. So let's have a very concrete example. Let's say that you are going to run a campaign in Berlin and you don't have a control group, so to say. You're going to have like maybe a TV campaign or with out-of-home, so a big one. And you want to estimate what could be the uplift of the impact of that on certain KPI, let's say conversions. So because of business requirements and also feasibility, you cannot split Berlin in two. You just have to have the whole of Berlin. So the question is, if I want to kind of test incrementality, I don't want to just see the whether there was an uplift on conversion, but the uplift relative to the counterfactual, which would be what would have been the development of conversions without any campaign or intervention. So
this is like a simulating an alternative world where something was
exactly, but you don't have two Berlins, so you need to proxy that. One possibility is use a city which has a very similar development of conversions, so let's say Hamburg, and of course you need to draw many assumptions saying, okay, they are comparable to a certain degree, and this is where your DACs come very handy, because maybe actually the conversion development of Hamburg and Berlin, no matter how close they are, could not be as close in that space, so to say. So for example, Munich and Berlin. And if you have one or many, you can actually use time-based regression or synthetic control with other type, because maybe Hamburg is not enough, but you want to have a better estimation of the counterfactual with many cities, and then you estimate what would have been the conversion development in Berlin without campaign, and then you can estimate that gap. Of course, the devil is in the details, so how do I select the geos, or what about boundaries, and to which extent this is a correct approximation? I think this depends on the problem itself. And there are many ways of solving this, but again, depend on the context. But in essence, that's what you want. So it's actually not that hard. It's hard to plan, of course, because you need to think which cities to control. But it's definitely not a silver bullet, but really convenient one, because there are some cases on where you cannot do like a proper split log or an A/B test.
How well, in your experience, those methods work in practice?
It can work surprisingly well. So under kind of very mild assumptions, you can get very good estimations. And again, in industry, of course, you care about the accuracy, but also you need to get something, right? A possibility would be, so instead of having a geo experiment, to simply try to estimate the counterfactual with a time series model, like a la causal impact, where you have a patient time structure model and try to just predict that. But then you're putting all the weight into the model, and it's not easy. I mean, predicting the future is pretty hard, and usually you have quite big uncertainty bands. So instead of making kind of forcing the model to solve the problem for you. What you then do is actually do this geosplit, have a much simpler model, let's say a linear regression or a synthetic control, to have better estimations. So in practice, of course, you can do, we need to do the cross validations to really see that we are not just estimating or seeing noise, but once you control for the uncertainty, which in this case is key, you can get a very, very good input from your campaigns.
One of the main challenges that we encounter while working with causal models is model evaluation. What are your main lessons from working with those models in practice?
All right, so I guess there are two components. The first component would be about really the DAC and the causal structure, and the other about the estimation process. So for the estimation, we have many statistical techniques to evaluate that. So let me focus on the causal component, and this is what I want to point out, that I actually learned a lot of these refutation techniques from your book. Thinking, for example, how stable is the estimate if you shuffle the data, remove some data, or add an edge on our graph, which shouldn't have any effect on the estimation if you put the arrows in the proper way. So I think those are the ones that I kind of use the most for cases on, like in marketing, like media mix models, where you have certain estimation of, for example, cost per conversion. You can then in parallel run some geo-tests or uplift tests to see in which extent this agree or not. I mean, if they don't agree, that doesn't mean the model is wrong. Again, these are all approximations. It might just be hinting us where to dig deeper to have a better understanding of the process.
When you think about causal reasoning and causal thinking, maybe in even broader terms, do you think that this is something that is only useful for people working with modeling?
Let's say the model part will be about inference estimation, but the causal thinking about how our intuition can fool us is something that, in my opinion, should be more spread across the industry. So if you are making any type of decision, you are essentially thinking causally. So even if you don't work with a specific model, but for example, you're a business analyst or a marketing manager or someone trying to look into data and take decisions out of it, and if at their disposal they have a dashboard, let's say just by adding filters or filtering by variables, which could be in this case colliders of your treatment or campaign, you could be actually getting a contradictory result. So what I'm trying to say is that having certain fundamentals of causality without going into the very kind of core formalism is definitely something that decision makers should overall have, because we can all be, and I've been fooled by my intuition.
Mm-hmm. Speaking about human intuition, I must ask you this question. You're a father as well. Sometimes we say that humans are very good in causal reasoning. As a parent, did you have any experiences with your kids where you would see an evidence or a counter evidence for human capacity for causal thinking?
I mean, of course, humans learn very fast, but I have a nice story about, we live in Berlin, so my son, he was born in November, so when he was a year old, around 10 months, it was already the fall in Berlin, so we would go outside, and it was not that cold, but when it was getting colder, we would put him the gloves. Mm-hmm. And then maybe the first times he was actually not keen, and actually he fought a lot about putting him hit the gloves, because he would associate that putting the gloves will imply that it was going to get cold. And he didn't like that. And of course, it took just a couple of times, and then he understood that the direction was in the reverse order. So I do think humans can think causally, but it's not on the first kind of iteration. It's really about really learning and iterating. But I think causality, at least from what I've seen from my kids, really comes from experience and iteration. And that's why kind of even as grown-ups, so to say, and I've seen many people being fooled by their intuition, because causality is definitely something not trivial. Mm-hmm.
So he was basically thinking that the causal direction is the other way.
Exactly.
He's putting on the gloves, and then it becomes cold.
Exactly.
I would love it to be like this. I would never put the gloves on. I want to go back for a second to your PhD and geometrical analysis. I remember that one day, Michael Bronstein, who is one of the godfathers of geometric deep learning, retweeted a tweet where another person, a Ph.D., a doctorate professor maybe, I don't remember who that was, shared an email that he received from one of his students or followers. And this person was asking him for a career advice. So this person said, hey, I'm really interested in geometry. I feel that this is something very fundamental, very basic. I'm super interested in this. And I love the geometric deep learning and all of those parallels with physics and so on and so on. But when I talk about this to my friends, they tell me that I rather should do prompt engineering or do something with nerves or other technologies that are very, very hot now. What would be your advice, he asked. And the person cited by Bronstein said that his opinion is completely the other, that he should do something completely reversed. So he should go into study of geometry, because as he said, this is something fundamental. And those hot technologies and the way we operate with them, like prompt engineering, is something that will likely change with time, while this basic fundamental techniques and the basic fundamental understanding, working with those basic structures, is something that will always have value. What are your thoughts on this?
Yeah, I would agree with this kind of advice about really focusing on the fundamental. And it doesn't need to be geometry, but really on the things that are the backbone of the theory. So geometry could be one, but I guess maybe more fundamental one, which might have a wider application, at least in the short term, is, for example, linear algebra and probability theory. If you really understand these two fields and have intuition, and of course in parallel know how to do this with software, you are halfway through. Coming back from that time when I was going from academia to the industry, for me the biggest challenge was to understand kind of how this works in practice, the business problem, of course certain techniques, but learning the idea behind our linear regression or a support vector machine, it was relatively natural thinking as linear algebra. And there are many examples for that, because I guess nowadays linear regression is still a thing. I would say that 80% of the problems at the industry can be solved with a good linear regression. But there are other things that fade out. So I don't know if you remember about Hadoop. Everyone was talking about Hadoop. And I remember when I joined the field, I was like, okay, I need to learn about Hadoop, MapReduce, and then RDDs and Spark. And now, let's say, I've actually never used Hadoop, and I have proven and provided a lot of business value. So, but these things fade out. So for this Hadoop example would be, okay, what you actually need to learn, it's about really system design and about how a computer works and how this actually scales up, and whether if you want to do it in Rust, in Java, in whatever language, that's not the problem. So that's on the computer science side. On the math side and statistics, I would say linear algebra and probability. If you have that, you're halfway through.
Mm-hmm. If you could make a bet, what would be your bet regarding causality? Is this something that will stay with us for a decade or longer, or this is just a trend that we can see?
I mean, I really hope it's not a trend, because this is one of the things that kind of it's fundamental for humanity, in the sense it's really about decision making. So it's really like a framework to have a better decision making process. So I guess like the work that you do in really democratizing this knowledge is something that we need to do more, because what it would be problematic is that it's maybe a topic now, but maybe people in the industry feel like it's too hard or maybe not worth the investment, and it will just fade out. So I think we still need to work on having more causal education and kind of way of thinking in the industry. I hope and I'm optimistic about that, but kind of we need to make sure that we don't treat this as a hype or as a tool, but really as a fundamental concept for better decision making.
What learning resources would you recommend to people who are just coming to causality? They want to start learning about this, start implementing in their work.
I guess there's no linear path, and fortunately for us, there are many good resources. When I started, it was a little bit less well known, or at least it was not clear for me. So, for example, in my case, I came from a Bayesian kind of framework, so to say, and the way about this book, Statistical Rethinking, introduces causality within the Bayesian framework and looking into probabilistic data generation process and DAX in the causal sense seemed very natural. For me, that was a great entry point. I guess the book by Pearl, if you like the theory as well, my advice would be that always kind of go with those type of books and then try to do some coding on the side, because they can feel a bit too abstract. So definitely having some code around and doing some simulation is something that it's much appreciated, because it kind of makes this intuition more tangible. And I guess really about the fundamentals. And if you want to have more survey-like or go into specific software, your book is a great resource, of course. And the book by Mateus on causal inference, Brave and the True, is also a great introduction. So I guess one of the things that all of these books have in common is that there's some code, so that you actually generate some intuition with it, because otherwise it's very easy to get lost in the details. And that's why kind of, in my opinion, the way of really grasping these topics is through, of course, reading the literature, but running some simulations and examples by yourself. And also trying to see when the assumptions break, right? Let's say what I always try to do is, okay, there's a nice example in this book, it works. Let's see how much do I need to distort the data or the assumptions to break it, to get a feeling about how sensible it is, because I have also designed or tried to solve some problems that work for a specific case, but then I'm overfitting the methodology into the data. And then I say, okay, the data is probably going to change. What if we change the data a bit? Will the method still work? Sometimes it does, sometimes it doesn't. So having the code close to you helps you kind of do this scenario planning and changes in the assumptions.
It's worth to keep a childlike curiosity a little bit in the output.
Of course. And of course, this is a key part. And really don't trust everything that you read. So try to challenge that as well. And yeah, of course, curiosity is the key component here.
What would be your advice to people who are just entering the field of machine learning, or maybe Bayesian modeling or causality, and they feel maybe a little bit overwhelmed or unsure if they can grasp all of those concepts that are needed to make it something functional?
Yeah, actually that might, I was there, and that creates a lot of anxiety about what should I learn? Is it like deep learning? Should I learn already like TensorFlow and JAX and PyTorch? But again, I think it comes back to fundamentals, but also solving concrete problems. And by concrete problems, I mean really business problems. But if you don't have yet business experience and you're actually at university, for example, try to find a problem that you're interested in and trying to do some basic data analysis. So something that is in my experience, when entering into the field, in Colombia, we had like a referendum about a peace agreement that happened in 2016, if I remember correctly. And the results were that the overall, it's a little bit controversial, but the no win, where people vote against that. And I was very curious about understanding kind of the geography and the distribution. And the public data was displayed as a map. And we have many districts, or let's say states in Colombia, and I wanted to go at city level. So what I did is build my first scraper with beautiful soup, nothing fancy, and then build the scraper, fight with the HTML. There were certain cities where the page was broken, so your if statement and so on, and collect the data, parse that into pandas data frame, do some visualization, and that's it. There was nothing fancy, and I think that's one of the big first blog posts on my blog. But then I learned so much about it, really about what was the core of it. It was not really about kind of fancy machine learning, but having some experience in doing that. And it was a great learning experience. So I guess, of course, there are courses, there are books, but that fades out relatively fast. I would say going through the pain of solving a very concrete problem which interests you, it's a great way. At least it worked for me.
Mm-hmm. How did it work for you regarding your motivation when you finished this project?
I mean, I felt like I could do it, first of all, so I didn't suck at programming. And also it comes back to the kind of mindset that you don't need to just see the end goal, but break up the problem into pieces and then solve one by one. And then you can see the progress. Don't get overwhelmed to what's next. Actually just embrace the journey, so to say. And at that time, I was actually quite keen in continuing, because at that stage, I was still not sure whether I want to do this or not. At that time, and maybe today, I don't consider myself as a software developer. So my coding skill is something that I've kind of gathered with time. But it's really about curiosity and being open to learn new stuff.
Is there any question that you would like to ask me?
Yeah, I mean, I guess I asked, what's your motivation on democratizing causality? Because at least for me, I mean, I learn something, I use it in my work, and from time to time provide a blog post, which is not that maybe big as having a book or a podcast or all of the things that you do. Where do you find this motivation about really making this more accessible to people?
That's a great question. You're not the first person who asks this. At some point in my life, when I was in a very dark moment, I was able to learn a lot thanks to people who just decided to share their knowledge, their experience for free on the internet. And I'm immensely grateful for this. And I don't feel like I have to, but I really want to pay back to the community. So that's the core motivation behind all of this.
And I think that's fantastic, because everyone, at least I've gotten have gotten quite a lot of benefit from that initiative. And I actually, the newsletter, like it's a little bit of a pain because it's piled up all of the things that I need to keep reading, but I find it quite nice.
Great, thank you. I'm so happy for this. This is the greatest reward for me if somebody finds this interesting.
Definitely, absolutely. I mean, you can find the book in my library already. I don't know. I think, of course, family and my parents and my wife. I mean, they're always been very, very supportive. When I started studying physics in Colombia. Unfortunately, we have a mindset on which kind of someone who studies physics or natural science is doomed, in a bad sense, to become a professor at high school. But my parents were like very supportive. It's like, no, it's really about what you want. And then they also open their mind. And for example, they support me to embrace those studies and not become another engineer. I have nothing against engineers, but I didn't want to do it. And also the fact that they will support me mostly kind of really emotionally to embrace this opportunity in Berlin to pursue my studies in math. And for them it was not easy because of course I'm not in Colombia with them, but they saw this actually it was better for my future, and I've always found support from their side. And now with my wife, she's also a PhD graduate. We had to be together, let's say to survive together to that time. And of course to her I owe everything I've done in Berlin.
Was there any particular thing that your parents did that made you feel really supported by them?
Being there, like it's not really about kind of money or actions, but just the fact that if they're there, you just feel this support to keep going, and that if you fail hard, no matter how, they're always going to be there to help you stand up and keep going.
That's beautiful.
I'm very fortunate, so to say. I feel very, very lucky.
That's really beautiful. Juan, that was a pleasure. Where can people find more about you or connect with you? Where they can find your blog? How they can reach out to you?
I guess you can look for me in LinkedIn, also in my blog. Probably you'll share that. Easy to find. There are not many Juan Orduz working in causal inference and Bayesian methods, but you can always drop me an email. People have reached me through emails, and sometimes my time is limited, but whenever I have time to support, we can bounce ideas and just talk about interesting topics.
We'll put the link to your blog and your webpage in the show notes.
Thanks.
Thank you so much. I really appreciate your time.
Thank you.
It was a beautiful conversation.
Thank you for coming on. Anytime you want to come to Berlin, mi casa es su casa.
Thank you for staying with us till the end, and see you in the next episode of the Causal Bandits podcast.
Who should we interview next? Let us know in the comments below or email us at hello@causalpython.io. Stay causal.